Chem 1251 pre-lecture video, Significant Figures. As you've probably noticed, chemistry involves lots of numbers. Some of the numbers are found in tables, some numbers are measured, while other numbers are calculated. The types of numbers in this course can be divided into two general categories: exact numbers and inexact numbers. All exact numbers have defined values. For example, 1 foot will always equal 12 inches, and 1 mile will always equal 5,280 feet. In each of these two conversion factors, the ones are exact. 12 inches is also exact, and so is 5,280 feet. Exact numbers are relatively easy to deal with because those values never change when we do calculations. We can say that exact numbers have certainty. Inexact numbers are trickier, and we will define inexact numbers as those numbers obtained by any means other than counting. If you pour liquid into a measuring cup calibrated to the nearest ounce, your measured volume would be reported to the nearest tenth of an ounce. Similarly, a thermometer calibrated to the nearest degree would have a measured reading to the nearest tenth of a degree. We always add one extra digit for measured inexact numbers to reflect the uncertainty in our measurement. There is a true value to any measured amount, whether it is the liquid in the measuring cup, the temperature from our thermometer reading, or anything else we may choose to measure. How close our measured value is to the true value is called accuracy. The numbers that are used to reflect our measured values are called significant figures. For this slide and the fourth slide, we shall focus only on identifying the correct number of significant figures. First, the integer numbers 1 through 9 are always significant. In our first example, the number 21 contains two significant figures. Even if we have a decimal point in only the integers 1 through 9, as in the case of 37.6, we still count the same way and ultimately obtain three significant figures. Next, the zeros found between integers 1 through 9 are always significant. For example, the number 307 contains three significant figures. If we have more than one zero between two integers, each of those zeros are significant. Thus, the number 10.009 contains five significant figures. It is possible to transcribe any number into scientific notation. Let's consider the number 32,057. Based upon the preceding information, this number contains five significant figures, and when written into scientific notation, it is 3.2057 times 10 to the fourth. The numbers preceding the power of 10 in scientific notation are always significant. Thus far, we've only considered numbers made of integers 1 through 9 and numbers where zeros are between these integers. What happens if we have zeros preceding or coming after integers? Let's look at the next slide to find out. Zeros occurring at the beginning of a number are not significant. The number 0.0027 contains two significant figures. The zeros preceding the number 2 are sometimes known as leading zeros. These zeros serve the role of placeholder. They are present to indicate position and nothing more. Let's convert 0.0027 into scientific notation. When we do this, we obtain 2.7 times 10 to the minus 3. Clearly, this number only has two significant figures. However, it is not possible to expand this number without having the leading zeros present. Let's try another example. 2.13 times 10 to the minus 4 contains three significant figures. When we expand the number, we obtain 0.000213. The zeros preceding the number 2 are serving as placeholders and are thus not significant. When zeros occur at the end of a number and are to the right of a decimal point, they are always significant. The number 9.0 contains two significant figures. Similarly, the number 0.1000 has four significant figures. The difficulty arises when we have zeros at the end of a number without a decimal point. Let's use the number 3200 as an example. The numbers 3 and 2 are significant because they are integer numbers between 1 and 9. We cannot say for certain whether the zeros after the number 2 are significant because we do not have information on how this number was obtained. 3200 may very well contain 3 or even 4 significant figures. In the absence of such information, the best we can state is the number 3200 contains 2 significant figures.